So the test is made up. Test is made up. I'll give you some hints about the test today as well. Your test is in a week. I took some of the questions from the test and I stuck them directly on the unit review that I'm going to give you. I changed the numbers. And then I took some questions from the quizzes that you've had. This is quiz 3, and then I'll also be giving you quiz number 4 today. That'll cover about 85% of the test, and I'll drop some hints about the rest. Meanwhile, let's mark this. We have good old Anne. So I can use A to the right, constant speed, B to, this is interpreting graphs. First thing I ask is, what kind of a graph is this? It says it's a position versus time graph. So how is he moving? Now, I noticed that I said part 1. There is no part 1 on here. Hopefully you all clued that this is part 1. I think it got covered up by the graphic. It's moved over the years. Anyways, how is he moving in part 1? What does a positive straight line tell you? Positive slope means traveling how? Forwards, backwards, or at rest? Or in this case, to the right. What would speeding up look like? Curve. Okay. So I'm going to say, I think, is 1A? Yes? How is he moving in part 2? What kind of a graph is this? Position versus time? Oh, E, at rest. How is he moving in part 3? Negative slope means negative speed or negative velocity to the left. Straight line, constant speed. B. How is he moving in part 4? At rest. In fact, he's at rest where he started from, back at the start line. But A, E, B, E. Let's do that in red so it stands out. 1 mark for each of those. By the way, what if this had been, I didn't write this, don't write this down. What if this had been a velocity versus time graph? What would this mean? Speeding up, going which direction? To the right, in this case. They gave me a direction, I'll say to the right. What would that mean if this was a velocity time graph? Not at rest, constant speed. That would mean slowing down, decelerating. What would this mean? That would be at rest. What would going backwards be? Below the x-axis, which I didn't have room here. Okay. Oh, I gave you a velocity time graph. Oh, same graph. There you go. I didn't even realize that. How is she moving in part 2? Does that mean at rest on a velocity versus time graph? No. That means constant speed above the x-axis or below the x-axis. Above, which would mean to the right. So A as well. Is that right, I think? And how is she moving in part 4? That would be E, standing still at rest. I, again, Derek, find that for the graphs, I will, if you saw me doing an answer key, you would hear me say out loud, okay, what kind of a graph is this? And then in my mind, I'm talking to myself. As soon as I identify it as velocity time graph, how high is how fast, the slope is the acceleration, above the x-axis is forwards, below the x-axis is backwards, as opposed to the distance where all that is the slope. Okay, draw position time and velocity time graphs for the following situation. I'll do the position time graph first. I'm going to say all of us should have the same shape. You might have drawn your lines longer, Jaden, because I didn't give you any time factor. That's fine, but we should be the same shape. If you have questions, you can lawyer with me afterwards. I'm going to make each one of these worth 2 marks, because I think in each one of these you end up drawing a total of 4 lines, so it's going to end up being a half mark per line. It says this. A student walks at a constant velocity down the hall away from her locker. I called this going forwards because I assumed if she's walking away from me, I see her back, which means she's walking forwards. If you called this going backwards, talk to me after and I'll look at your graph. But I said constant speed going forwards. She stops. This should be a horizontal line of I don't know how long. She runs backwards. Now, I'm going to be fussy. Backwards is going to be downhill. The fact that she's running, you'll look at your line. Your second line should be steeper than your first line. So I'm going to say there's running, steeper than walking, and stops at her locker as she looks for a book. I would give you a half mark for each of those 4 chunks. If you're missing one of those chunks, you lose a half mark, or if you have an extra chunk, you lose a half mark. Does that make sense okay? And again, same shape. You might have gone shallower here for walking, or yours might be longer. That's fine. But I'm telling you, you're going to start off with a straight line, positive slope, not as steep, horizontal line, negative slope, steeper than your not as steep, horizontal line, 0 high. What about the velocity versus time graph? Okay. Walks at a constant velocity. Suddenly she stops. Now, if you connected them, I have no problem with that. I haven't really talked yet about how these connect. This is where Hannah graphing really breaks down. We're going to go to equations next unit, and then we can connect them mathematically and find the instantaneous speed wherever, because we have an equation. It's going to be plug and chug. But so if you have that line there, great. If you didn't, because often I've left it off, I'm fine with that. After a short pause, she runs backwards. What would backwards look like? Runs, what would that look like? Further down. So I'm going to do this just to make it easier. Here's walking. There's running. Definitely, I'd be looking for a further distance. Oh, and then she stops at her locker, so she's at rest. I think we'd see something like that. Hey, 4 lines, half marked for each line. Okay. Can you give yourself a lovely score then out of 2 plus 2 plus 6? Oh, it is out of 10. Give yourself a score out of 10 there and make sure your name is on it. Lawyering with me, now is the time to ask. Let me pause the video. Last day, we looked at this notion called relative velocity, this idea that, you know what, you can have 2 objects moving at different speeds, pretend one of them is standing still, and use the relative velocity between the 2 of them. I'm going to start out, there was some yucky ones from the homework. I am going to say, I like question 1 and 2. I like question 1 and 2. I like question 1 and 2. Question 1 and 2 are nice questions. And I like question 5. I like question 5. I like question 5. Question 5 is a nice question. The other ones are good practice as well, but those are the ones that I think are kind of fun. Were there any of these that you tried? And apparently not all the answers matched. I got more answers because I nuked some questions. So apparently 1, 2, 3, 4, 5, 6. Well, there's 7 answers. Oh yeah, because there's only, there's the answer to number 2, and there's the answer to number 1. So I nuked some questions anyways. So you won't end up crossing out everything, but you should have found your answer, I hope, down there somewhere. Okay, any of these that you want me to go over, now is your chance to ask. Yes?
306.
Yep. Any before number 6 was nasty, which is why I put it. Okay. Any before number 6? Sorry, I heard someone. No? Did someone say 3? I thought I heard someone say 3. No. It's number 6? 6? 6. Okay. All right. I'm going to eventually, I think, go everything in meters per second because I got kilometers per hour, but I got the track in meters and a distance in meters. Here's what I said. Let's pretend everything is standing still. This is what we can do with relative velocity. How far is Scott Goodyear behind Mario Andretti, or how far is Mario Andretti behind Scott Goodyear? How many meters, Sam?
700 meters.
I said he has to make up this. Then I said, what's his relative velocity? Mario is going how fast? Scott is going how fast? I said the relative velocity is 30 kilometers per hour. And then I said I'm going to change that to meters per second. Kilometers per hour to meters per second, it's something to do with the 3.6 divider times 100 kilometers times is 2, divide. Or it's on your purple sheet, but this is how I figure it out every time. So I went 30 divided by 3.6, and I said, okay, 8.33333. Since this is not my final answer, I'll carry a few extra sig figs. I said I'll use or I'll use my answer button. Well, I can tell you how long it will take. In fact, I can use this equation here, the equation that has a d, a v, and a t in it, which is that one. Only I'll get the t by itself. Sam, how would I get the t by itself? Yeah. It's going, if they were standing still, which they're not, but if they were standing still, it would take, I'll use my answer button cleverly. Oh, that worked out great. It's going to take him 84, what? 84 seconds. You okay with that, Ty? I use d equals vt, and I use, because two objects, different speeds, I use the relative velocity to find the time between them. You okay with that? Are they standing still? No. So, actually, how fast is Mario going? So I'm going to go 200 what? I got to convert that. 200 divided by 3 points, because my time is in seconds, so let's do this. And the track distance length is in meters. 55.56. How long is he traveling for? 84 seconds. How far will he go before he catches up? I'm looking for an equation that's got a v, a t, and a d in it. Ding, 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 ding. Okay, so he's going to travel 55.56 times 84. I'm going to use my answer button. That's how many meters are going to have passed before he catches up. 466. This is not my final answer, so I'll carry extra sig figs. 4666.67 meters. How long is one track lap? Do you have it in front of you? Oh, he didn't open to the home. Okay. 1250. So how can I figure out how many laps that's going to be? How many laps is 4,666.6 repeating meters if one lap is 1250? Ah. Now, there's a lot to this question. But you know what? I figured it was a racing question, and this is some of the stuff. If you're wondering how video game physics does all this stuff to make sure things catch up and intersect, this is what they'd be running through if it was a racing game. So I'm gonna. What was one lap, Kareem?
1250 meters.
3.73 laps. That's when they'll catch up. Mr. Dueck, what Nevada? Is that fair game? I have no problem asking you to find time for one object to catch up to another object using the relative velocity. Or I would, if I gave you the time, I would have no problem asking you to find the relative velocity between the two, like the cops and robbers question that we're going to do later, or that you're going to see in the future. I might not even, as a nasty, have a problem asking you to then say, okay, what if they're not standing still? How far will they travel? I doubt I'd then throw the laps in there and have you divide by that. I would consider this an A- level question. I might be okay putting this as a nasty multiple choice question, like the one to really throw a curveball, but I don't think I give you one this difficult as a written. In fact, I know I wouldn't give you one this tricky as a written question. Is that okay? Any others? Sorry, did someone say 7? 7. Can do that. Let's go find it, Mr. Duke. Oh, I think I used my block D, didn't I? That's right. Oh, Acrobat did an update and went to a new screen. Okay. Accept. Are you guys like me? I never read those user agreements either. It's a bad habit because I'm sure one of these times it's going to say, we have access to your bank account or something stupid like, okay, I got to pause the screen here. Hang on. Pause the, wow, you're a techie, Mr. Duick. Sorry. Number 7. This is, all that was so I could go like this. Copy. Okay. Nevada, I'm going to draw a little picture. I'm going to put, is Calgary east of Banff or west of Banff? Any Alberta people here? I think Banff is here, Calgary is here. So here's Nathan, here's Jill. There's the cars. This is why I type most of my stuff. I can't draw to save my life. You okay with that so far, Nevada? Seems to me I can do that. How fast is Nathan traveling? I'll call that VN. V Nathan? Clever me, yes? How fast is Jill traveling? Okay, now I've got a visualization here. Okay. By the way, kilometers per hour and the distance is in kilometers. I think I'm going to do this whole thing in kilometers and per hour. I'm not going to convert everything to meters per second. Are there two objects? Are they moving at different speeds? Hey, this is a job for relative velocity. I'm going to pretend that one of them is standing still. I'm going to say that the relative, what is the relative velocity? Is it 15 kilometers per hour? Because do you go 105, take away 90? Or are they heading towards each other? So what is the relative velocity here? If I pretend Jill is standing still, relative to her, how fast is Nathan traveling? 195. We add them up, right? And if I pretend Jill is standing still, how far does Nate have to travel? $140. Mr. Dewitt, they're going to meet somewhere. Yeah, I know that. But I'm going to tell you, if you add up their total distance, it's going to be 140 kilometers, whether Jill travels more of it or whether Nate travels more of it. I'm telling you, the total distance is going to be that. Can I find that? Hey, I'm looking for an equation that has D and V and T in it. I think I can. I can go, how would I get the T by itself, Nevada? Divide the V, you said? I agree. It's going to be 140 divided by 195. I suspect this is going to be a yucky decimal. That's what I have a good answer button on my... Hopefully your teacher went on a rant at the beginning of the year about the importance of having a good calculator. They're going to meet after 0.7179 hours. I'll go 0.718 hours. That's when they're going to meet. Where? Now I'm going to pretend that they both aren't standing still. But I am telling you, Jill will go for 0.718 hours. Rob will travel for 0.718 hours. In the answer key, you know what? Since in the answer key I said from Banff, I think what I'm going to do is I'm going to look at Jill from Banff. How could I figure out how far she travels? So there's my relative. I pretended they're standing still. Now I'm going to pretend in real life they're not. So I'm going to find the distance that Jill is going to travel. Oh, what's the speed that Jill is traveling at? 105? How long is she traveling for? 0.718, blah, 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 blah. I'm looking for an equation that has d, v, and t in it. There is one. You know what? It's going to be 105 times 0.718, blah, 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 blah. Let me try it. 105 times, I'm going to use my answer button cleverly, if that's okay, Nevada. And it looks like she goes for 75.4 kilometers. Is that what the answer says? I hope. Is there from Banff 75.4? How far does Nate go? 140 minus 64.6 kilometers from Calgary. So you'll notice Sam and Nevada, 6 and 7 were very similar in that. I said 2 objects, relative velocity. I pretended one was standing still. I said, what can I find? Time, distance, what? Then I moved over back into saying, hey, they really aren't standing still, but I still can use d equals vt, or v equals d over t, or t equals d over v, whatever the heck they'd wanted me to find. Is that all right? And again, I would consider that nastier than you're going to see on the test. Any others? Were there any questions from the instant, because I also did say I would take questions from the interpreting graphs sheet, of which there are still a couple of answer keys floating around here, and I did put my answer key online. Were there any of these that you were going, Duick, I have no idea how the heck you're doing this? There are going to be 4, sorry, that's a lie. 1, 2, 3, 4, 6 or 7, where I give you, say, a distance versus time graph, and I say sketch the velocity versus time, or I give you a velocity versus time graph, and I say sketch the distance versus time, or the acceleration versus time on your test. In fact, I think I might even have lifted a couple of questions almost right from here and just changed a few things. Any of these that you were going, I have no idea how to get this? So as far as I'm concerned, this is due today as well. Oh, yeah.
Are there going to be like any other more complicated ones on them?
I don't know. Can you find, like, was there one that you couldn't do that you want me to go over? I'd happily do so.
Yeah.
Can you find a specific example? I'm saying question number what, sir?
19.
Number 19? Okay. So in number 19, since I actually gave you numbers, what is the velocity here? What's the slope of this line? What's the rise? 56, right? What's the run? So what is the velocity? All I'd be looking for is this. There. You could have drawn yours higher or lower, but I'd be looking for that. By the way, what's the acceleration? Because it's a constant speed, isn't it? Yeah, that one is totally fair game. I wouldn't have asked number 19, because I think when we start with the actual values, probably number 19 was the easiest of the actual values. I figured you'd be jumping to like 22 or 23, but okay. That's how I'd do that one. Any others? This is your chance to pick my brain. So I will still take questions about this next class. So what do I have for you today? 2 things. Take-home quiz number 4, which is pretty big. Probably take you about 25 minutes, which you probably can get it done in class. And then I have the unit review. Let me hand those out, and then I'll talk about it. And then the rest of the class is yours. Take a look at quiz 4, okay? 45 marks. Yeah, it's a mini test, actually. It's got a little bit of a review of everything. So you'll see there's some calculation questions where I'm asking you to find either distance or speed or time. Echo question. Hey, I like that question. I like that question. 4 is a bit of a mini curveball. See if you can figure it out. 5. Oh, let's see. I see 2 objects in number 5, a rabbit and a wolf. I see them traveling at different speeds. Probably a job for relative velocity. Number 6. I like number 6. I like number 6. I like number 6.
Is that going to be on the test?
Did you hear me say that? Or you're the kind of student that tends to notice certain things? Okay. 7 and 8, kind of conceptual stuff. Number 9, find an average speed, meters per second and kilometers per hour. So do a little conversion. Psst. You don't do that again. More. Number 12, I think what does the slope represent? Then we're going to interpret some distance versus time graphs, interpret a velocity versus time graph, and then sketch some of these here things. What isn't on here? Nowhere on this quiz. Well, here's where I gave you a velocity versus time graph and said, give me the acceleration. So a little bit of that as well. Then if you look at the unit review study guide, because I haven't done as much velocity versus time graphs compared to the amount of time we spent on distance versus time graphs, you're going to notice a lot of the graphs are speed versus time. And I did want to talk about number 14. That's this one right here. For some reason, when I photocopied these, when they shrunk down and things got a little bit warped. You can assume that both of these lines have the same slope. And so to find the slope, Kareem, I would use line B, which definitely goes through 5,70. Let me turn the eraser on so you can see it. Definitely goes right through there and definitely goes through 0, 0. I would use rise over run that way. Asks you to find acceleration, asks you to find the initial velocity, actually asks you to find the equation using y equals mx plus b. That's fair game. Another speed versus time graph, another speed versus time graph, another speed versus time graph. Then sketch the missing graphs. So you'll have this on your test. I'm going to give you a distance versus time graph and say sketch the velocity graph that goes with it. Then number 20, 2 trains, different speeds, relative velocity. 21, 2 trains, different speeds, relative velocity. Police car, bad guy, relative velocity, relative velocity. And then here, what I didn't have on quiz 4, the instantaneous velocity of a curve where you have to lay the ruler down. That will be on your test as well. So here's some questions. I did this answer key last night, and things were going great. And then, God bless her, my mom phoned me up for computer help. And so I was trying to do my answer key while at the same time trying to explain to my 72-year-old mother how to do things on Windows. No guarantees that there aren't mistakes in this answer key. Same as usual. If you find a mistake, check with a neighbor. If you're sure, candy for you and I'll fix it. You guys will be my proofreaders. Okay? You have all class. You definitely want to get quiz 4 done today. On Wednesday, I'll take questions from the review, but all we're doing on Wednesday is finishing off the review, any other missing assignments, and marking quiz number 4. Your test is Monday. I'm shutting up.